So we know how to deal with bit flip errors. How about phase flip errors? You may remember from one of the earlier lectures when we looked at quantum circuits. We wrote at some point the circuit identity, namely the bit flip can be always written as phase flip error sandwiched between the two Hadamard gates. The same goes for the phase flip. It can be written as a circuit where we have Hadamard followed by the bit flip followed by the Hadamard. So here is an idea. If we have Z-type errors, phase flip errors, what we can do, we can repeat essentially what we did just a moment ago, except that we are going to sandwich the decoherence area between the Hadamard gates. So as you can see, what I did here, I put the Hadamard on the left side and on the right side of the decoherence area. So if phase error happen here, they will be seen by the circuit outside the Hadamard as bit flip errors. So this identity here is very important, and it helps us to switch between the phase flip errors and the bit flip errors. And now essentially I can repeat my narrative. Instead of bit flip errors, now we have phase flip errors, and you may perhaps one slight difference to the narrative would be the code space. You may now incorporate the Hadamard into the encoding part. So you say, well, the state alpha 0 plus beta 1 is then encoded in the state which is alpha 0, 0, 0 bar, and this is the bar basis here is so 0 plus 1 and 0 minus 1. So now you can see that we, in the process of encoding the state alpha 0 plus beta 1, is then inserted into this 8-dimensional Hilbert space associated with the 3 qubits that we have here. But the code space now is spanned by 2 vectors, and it is 0 bar, 0 bar, 0 bar. That's one of the basis vectors, and the other one is 1 bar tensor 1 bar tensor 1 bar. And the rest of the procedure is essentially the same. So now you know how to deal with bit flip errors, and you also know how to deal with phase flip errors. So the next stage is to see whether we can deal with both. Can we just design a circuit which helps us to encode one qubit in a certain number of qubits, and then we will assume that both phase errors and bit flip errors can happen, and let's see if we can recover from those errors.